Hi, I'm Benny D, and in this video we're going to be looking at tangents and normals. So tangents have the same gradient to the curve where they touch, and we use the equation of y minus y1 equals m outside of x minus x1 to find the equation of our tangents. Okay, and normals are perpendicular to the curve where they meet. Okay, and we use the equation y minus y1 equals -1 on m outside of x minus x1 to find our equation. Okay, the difference here is our gradients, where we would have used these forms of our equations a while ago when we were doing linear equations, and we will use rise over run to find these m values. Now what we're going to be doing is finding our derivative of a function, subbing in a value and getting a gradient of our tangent or normal through that. Okay, so we'll do this through a few worked examples. So we've got find the equation of the tangent to the curve y equals x cubed plus a half x squared at the point x equals 1. Okay, so what we need to be thinking is I need to end up with a value for y1, for x1, and for m. Okay, now x1 they tell me it's 1. Okay, so we need to work out what y1 is going to be. So I need to sub 1 into here. So we're going to get 1 plus a half. Okay, so we're going to get 3 on 2. Or 1.5. Okay, the next thing I need to do is find my m value. Now to do that, I need to find dy dx, and that's going to equal 3x squared plus x. Okay, just by bringing our powers down the front and taking 1 away. Okay, then I'll go say let x equal 1 because we need the tangent at the point x equals 1. Okay, then dy dx. Okay, well, that's going to equal m value, and that's going to equal simply subbing 1 back in here. We're going to get 3 plus 1, which is 4. So m is going to be 4. Okay, once we've got that information, we just sub it into our formula that we've got here. So we've got y minus y1, 3 on 2, okay, equals m, which is 4, outside of x minus x1, which is 1. Okay, we might do some rearranging here to make this look a little nicer. So we've got y equals 4x take 4 plus 3 on 2. Okay, so y equals 4x minus 5 on 2. Okay, and that would be the equation of our tangent in this case. I've got a couple of examples to show you. So I'll put this one out. Okay, again, we're going to look at the tangent to the curve at x equals pi on 3, and our equation is y equals sine of x. So again, we're going to need y1, x1, and m. Now again, we've got x1 here as pi on 3. So we'll need to find out what our y1 value is as well. Okay. So when we sub in pi on 3 in the sine, okay, we get a y value of root 3 on 2, okay, from our exact values. Okay, and then we need to find our gradient. Okay, so we need to remember that if we've got y equals sine of x, then dy dx equals cos of x, okay, and when x equals pi on 3, okay, we get cos of pi on 3 equaling 1/2. And that's our m value. M value is 1/2. Okay, and again, we're using our tangent equation. So we've got y minus y1, which is our root 3 on 2, equals m, which is 1/2, outside of x minus x1, which is pi on 3. So you get y minus root 3 on 2 equaling x on 2 take pi on 6. Okay, and we'll finish it off. Y equals x on 2 take pi on 6 plus root 3 on 2. Okay, so we always want to rearrange these to put them in the form y equals mx plus c. Okay, we don't just want to sub our values in and just leave it. So we do need to do that little bit of working out. Okay, I've got one more example to do. Okay, this time we're going to be looking for our normal. Okay, equation of the normal this time. Okay, at the point 1, 1. Okay, and our equation is y equals x cubed take 2x squared. Okay, so this time we actually told two things. Okay, we actually told y1 and x1. Okay, so y1 and x1 are both 1. So this time we just need to find our gradient m. Okay, so we need to do our dy dx. Well, that's going to be 3x squared take 4x. Okay, we're going to let x equal 1, because again, remember, it's at that point x1. Okay, so our m value will equal 3 times 1 take 4 times 1. It's going to give us -1. Okay, so our m is -1. So this time, however, we're going to use our equation for our normal. So I've got y minus y1, which is 1, equals -1 over our m value, which is -1, x minus our x1 value of 1. Okay, just be careful. In our worked example, these have all been positive, but don't forget, to take a negative, you're going to be making it a positive. Okay, so we simplify this. Okay, so we've got -1 over -1, it's just 1. Okay, we add our 1 onto our -1, we're just simply going to get y equals x for our equation of our normal for this one. Okay, so that's the type of thing that we're doing in this section. Hopefully that's enough to get you through some of the questions you need to do.